Hello, my name is Caleb Harris, and this is my lab for Physics 2212 charge tapes. This lab's purpose was to observe the transfer of electrons between surfaces and to calculate the charge of those items. The main physical principles were Newton's second law of motion and Coulomb's law. In the next slide, you will see the models. The main result of the lab was that the charged pieces of tape repulsed each other, as in they were similarly charged. They're both positively charged pieces of tape, and they repulsed each other. And that the charge of each piece of tape was determined to be 1.35 times 10 to the negative eighth coulombs. For assumptions, I assumed air resistance was negligible. I treated the long tape as though it was a point charge, and I assumed each U tape had about the same amount of charge, and it was evenly distributed along the length of the tape. Here are the models that I mentioned in the previous slide. You have on the left we have force equal mass times acceleration, which is Newton's second law of motion, which helps for the gravitational force. And then we have Coulomb's law to find electrical force, which involves essentially you have the Coulomb's constant times Q1, Q2 over the distance between the two particles in newtons, and its magnitude of the electric force, or the net force. For my system, it was tape B and tape A, and my surroundings with everything else in the universe. Initial conditions, I have two equal length pieces of tape. They're both neutral at first, except for a third piece of tape, which is stuck to a table. And the experiment consisted of me taping one piece of tape to a table and having two neutral pieces of tape. And I pulled a piece of neutral tape from the table, and it's charged that piece of tape. I charged it, and I was able to test it by comparing it by holding it next to different charged items, and eventually next to the like charged piece of tape, which proved that it was positively charged and the same charge as they pushed away from each other. Then I measured that distance, which I didn't use in my coding, which you will see in the next slide. Here are some of my observations. The length is 0.2032 meters, mass is 0.00021 grams, and distance between pieces of tape was 0.0281 meters. Gravitational force with mass times gravity, gravity being 9.8 meters per second squared. And then we have E force, the absolute value of the weight, because I have to cancel since force net was equal to 0. And the U tape was positively charged and lost electrons while in contact with the table. And then here's the coding for part one. I simply just put in all the data that I got from my measurements of the U tape. Just like, of course, you have your K constant as Phys. I have my charge on my electron. I have a tape mass, tape width, tape length, the distance between them, and the gravity. And I simply just found the E force as well as the weight, and that gave me the tape charge. Of course, by using Coulomb's constant, by using Coulomb's formula. For part two, this is where I used to find the magnitude of the forces. Again, the magnitude of the gravitational force was just mass of the tape times gravity. I also know that since the net force of the system was 0, basically that the electrical force was just the absolute value of the gravitational force, and that was how I was able to find the gravitational force. I mean, excuse me, that was how I was able to find the electric force, because they're equal, because it's equal to the gravitational force. Here are possible sources of error. I could have made mistakes when I measured the tape, specifically when I measured its width and length. Additionally, the charge might have been lost when I touched the tape, when I handled the tape. More than electrons could have been transferred, which could have impacted my results. And the main discrepancy is that the charges are probably not exactly equal between the two pieces of tape, between tape A and tape B. For the what if question, if the charges were reversed, simply the directions would be reversed, but the charges will still act the same, as in the like charges will still repel each other and the opposite charges will attract each other. For the why question, handling the tape causes the transference of electrons, which will then affect the charge of the tape. And lastly, just to give a brief recap, this lab involved the transference of electrons between objects, and we explored that by using tape. First, by ripping off two pieces of tape. Well, ripping off a piece of tape from a table caused it to transfer electrons. We were then able to find the new charge of the piece of tape by comparing it to a like charged piece of tape, and they repulse each other. We then measured that distance and calculated the net force, which was then 0. But we learned that the gravitational force was is equal to the opposite direction is equal and opposite to the net electric. It's equal and opposite to the electric force. Thank you.